Hello everyone, today I would like to talk about my geology storyboard, and now I have the Metamorphic storyboard, which is much more conceptual, much more, this metamorphism is happening deep underground, so this is a little harder to imagine as opposed to our sedimentary rocks or even volcanism. First of all, we have our parent rocks or protoliths over here to the left side. So we have several different bodies of rock, several different layers, maybe a basaltic lava flow and then granite at the base, which is pretty common. Got some sedimentary rocks here on top, some shale, sandstone, and limestone. And as these bodies of rock are in some kind of compressional system, whether it's a subduction zone or a collision, that's okay. But either way, they're undergoing heat and pressure, right? So we're getting metamorphism. So along the bottom, granite can metamorphose pretty readily because we're just changing texture mostly. So we get some foliation here, but we have the same minerals and we get a rock called gneiss. Our basalts may form into something like blue schist, serpentinite, so we have something like that. Limestone will turn into marble. Sandstone will turn into quartzite. Don't worry about the colors. Quartzite marble can be lots of many colors. I know they don't match up with those. And then, as we're looking at the foliated series, if you know your foliated metamorphic rocks, we're starting out with an aluminum-rich or clay-rich sedimentary rock like shale, and then we'll end up getting slate, and then phyllite, getting a little bit of a metallic sheen there, schist, where we may get some garnets and micas, and then finally gneiss. Again, so we have two different gneisses here from very different protoliths or very different parent rocks, but gneiss can come from a lot of different kinds of rock. And then finally we may get migmatite. I don't have a sample of that right here, where we can get streaks of granite in a gneiss. So we're actually going full circle and beginning to melt. And all these things will melt eventually, right, with more temperature, but with reducing pressure, actually. Too much pressure prohibits melting, so we're not seeing that. But this is just a simple way to get protoliths or parent rocks and think about how they undergo heat and pressure and what kind of changes happen to them as they undergo metamorphism.